Hey all, enjoying making these videos for you, although I'm getting a bit of a sore throat, but that's okay. I'll just drink lots of tea afterwards. Last example for 5.3, page 278, number 19. Just pause this video now and go there and read the question. I don't want to bore you by reading it out to you. So now that you've read the question, let's just identify what's given. We're told that the distance between the highest point and lowest point that the buoy is bobbing is 1.5 meters. So the distance between the max and min, half of that would be the amplitude. So my amplitude is going to be 1.5 meters divided by 2, which is 0.75 meters. We're also told that it takes 6 seconds for the buoy to move from the maximum, the highest to the lowest, back to the highest. And so that is one full cycle. And therefore, the 6 seconds is the period of the buoy. And we're asked to graph the vertical displacement versus time. Let's do that down here. Time is measured in seconds, we're told, and vertical displacement, let's call that d, is measured in meters. Since my amplitude is 0.75 meters, that's where my maximum value is going to be, and my minimum will be at negative 0.75. It also says in the question in part A to assume that the buoy is at its equilibrium point at t equals 0 seconds and that the buoy is on its way down at that time. So what that means is that the buoy is starting at 0, 0, and instead of going up first, as it would for a sine curve, it's going to go down first. It asks us to sketch the graph over 2 cycles. So I'm just going to actually draw the shape of it first. That would be 2 cycles of my graph. And now I'm going to label the t-axis. So since my period is 6 seconds, I'm going to do as I did in the previous example, quarter periods, because I know that my important points for sinusoidal functions always occur at quarter periods. And quarter periods here would be 6 divided by 4, which is 1.5 seconds. So what that means is that this point here would be at 1.5 seconds. The next important point would be at 3 seconds. Next one would be at 4.5. Next would be 6. That's one full cycle. And same pattern over here. So 2 full cycles we know would go to 12, which means halfway to the second cycle would be at 9 seconds. Notice I haven't labeled every division. I've labeled every other division. I usually do that because I don't want to squish my numbers too much. Okay, so this is actually part B. I decided to do part B first because I find it easier to do the function from the graph sometimes, but you can choose, up to you. Let's do our equation of the function now. Make sure you use the appropriate variables. So instead of y, it's d equals the amplitude, which is 0.75. We're using a sine function because it starts at 0, 0. However, it goes down before it goes up, so we're going to put a negative in front of the 0.75 to indicate that there's a reflection in the x-axis. Now I need my k value. My k value I can get by doing 2 pi over the period, which is 6. So that's going to be pi over 3. Pi over 3t. And there doesn't appear to be any phase shift or vertical shift. So that is my function for this problem. And again, I just want to emphasize that the reason why I have a negative here is because the function goes down before it goes up, whereas normally sine goes up first. So normally sine would be like this. Well, it would be higher in this case, but something like that. However, it's going down first, therefore there's a reflection in the t-axis.